The next topic that we are going to discuss is the concept of abstract classes. And this is something that before to watch this video, you need to be familiar with inheritance, polymorphism, and interfaces, which are covered in separate video. Okay. The idea of the abstract class is to provide, again, an intermediary solution when you have scenarios for which, well, interfaces are not fully appropriate. Okay. So we're going to see exactly what I mean by this. Let's start with something concrete. Let's start with an example. Okay, we have a list class, and we want to implement. We have actually implemented the following two list classes. Okay, an array list class. So this is, let's say it's a subclass for now. Okay, and it implements a list of objects by using arrays, and then the linked list class implements a list of objects by using, well, a linked list. Okay, so we're going to say that we have a list interface for now. Okay, so we have already defined our list interface to say, okay, these are the methods I want to find in any sort of list of objects. Okay, I want to be able to add, I want to be able to remove the element at the front, and so on and so forth. Okay, and then we define two classes that implemented that list interface, array list and linked list, and each of them provided the code to make this happen based on two totally different strategies of implementation. Okay, one is using arrays as the underlying data structure, the other is using linked list. So some of the methods are going to be implemented the same way. That's bad. Okay, remember the DRY principle, don't repeat yourself. That means there's redundant code. So every method that works the same way, no matter, you know, whether you have your list of objects implemented with arrays or with a linked list, they are going to find themselves repeated in both of those classes. Why? Because the interface cannot contain code. That was the idea, right? A superclass can contain code that is common to all of its subclass. An interface does not contain code at all, which is not really 100% true anymore with Java 8, okay? But we're going to let that slide for now. So for now, let's say that the interface cannot contain any code at all. So what can we do? All right, so this is our problem. So two different implementation. I should have like triggered those animation before, but two different implementation, one with arrays. So if we have a list of, for example, integers here, so the same integers, 42, -3, 17, need to be stored in a list. Well, if we use an array list, it's going to look something like that in memory. If we use a linked list, it's going to have those three different objects linked to one another. Okay, so we're not going to go into the detail of what linked lists are and how to implement them. Our problem here is more conceptual, right? Every time we modify one copy of the code, like for example, every time we modify one of those methods that is common between the two classes, then we need to go update all the versions, find them, and then update them all by hand. So that's what we want to avoid. So let's talk about the limits of interfaces, okay? Our list classes, array list and linked list, share some common code. So let's say that these are the common methods, the methods that are implemented the same way, regardless of, you know, what data structure you use to implement the list itself. Okay, so add with a specific value contains that tests if a value is in the list and is empty. How do we capture this common behavior if interfaces do not hold code? And we know they don't. Okay, so should we change our interface to a class? Yeah, that sounds like a good idea first, okay? Because that's how we're going to be able to factor the code out of those array list and linked list classes, and so that we only write it once and for all. But then that means we fall back into that same trap of we can only have classes inherit from one superclass. So why did we use interface already to start off with? For flexibility or because we are forced to? Well, that's going to clash, okay? So let's take a look at something called abstract classes. An abstract class is an hybrid between an interface and a class. So it takes pretty much the best of both worlds. Like a superclass, it may contain method, declaration, or end method bodies. Okay, so this is really what's like a class. Method declaration, we have that already in interfaces, but method bodies, the code actually, no, we don't have that in interface. So it's capable to do that. And like an interface, some of the method or all of the method can, or may, I should say, not be instantiated. Okay? Okay, so that means that we can have some methods that, just like in an interface, have no body, and some methods that do have body. So this is maximum flexibility, right? We can decide on a method per method basis which one are actually implemented in the abstract class and which one are left to the subclasses of that abstract class to be implemented, just like classes that implement interfaces. So what goes in the abstract class? Implementation of commands, states, and behavior. So states mean fields, behavior means method, okay? And all those implementations are going to be inherited by the subclasses. So that's classic inheritance, okay? And then for those methods that were actually marked as empty, do not have a body, okay? And we're going to see exactly how we do that syntactically, okay? But those methods that do not have code inside the abstract class, they represent what we had in the interface, okay? These are methods that have absolutely to be provided by the subclass. So you can see how, once you understand interfaces and superclasses, you really realize that abstract class are really an hybrid between the two, okay? So let's take a look at the syntax. Well, public, class, and the name of the class, and you just add in between public and the keyword class, the keyword abstract. And that's it, okay? So that marks this class as an abstract class. And then inside this class, you can write method and fully define them like you do in any class. You can write fields and fully define them like you do in any class. You can have final fields that would be allowed in both classes and interfaces. And then you can have methods. Okay, so this is a syntax for a method that are marked abstract. And when a method is marked abstract, you don't have to provide the code. You just put a semicolon, right? Okay, so a class can be abstract even if you don't have any abstract method. That still allow you to pretty much prevent people from creating object of that class. It's impossible to create an object of an abstract class for the same reason that it would not make any sense to attempt to create an object that is from an interface. Okay, a class is meant to generate object. An interface, because there is only declaration of methods in it but no code, that doesn't make sense to have an object of a type interface something, right? This object could not do anything. You would call the method, they are not implemented. So the same thing happens here, okay? Once you mark a class as abstract, that's it. You cannot instantiate that class. So it's not a class that's meant to be used to create object. It's just a class that's meant to sit in your inheritance hierarchy, and then you are fully expected to create subclasses that inherit, that extend your abstract classes. And those subclasses are going to be responsible for providing the implementation of all those abstract methods. And if they do so, and if the job is well done, then you can create object of those subclass types. Okay, let's take a concrete example here. So let's go back to our idea of a list class. Okay, here's public abstract class abstract int list. Okay, so we make it clear in the name that this is an abstract class, so there's no confusion. It implements the interface list. So that means that it's going to provide implementation for this, and this method. Okay, so here's an example of implementation. To add an int value, I do this. To test if a value is in my list, I do this. And to test if the list is empty, I assume that I have a method size and I test it. Okay, then I can have a class array int list and a class linked int list that both extend our abstract int list. So they inherit not only does the method header, but also the implementation that are here, okay? So, how do abstract and normal classes play with interfaces? So let's try to sum up a little, compare like everything that we've covered so far, okay? So normal classes that claim to implement an interface have to provide the code for all the methods in that interface. So if you have, again, an empty class implementing a list interface, that's not going to do it. You have to have the code here for the method. Now, interestingly, abstract class, they may claim to implement an interface, okay, but without actually implementing its method. So let me try to explain what I mean here. Here's a public abstract class empty. That's the name of the abstract class. It says that it implements the interface list, but it's empty. But this time, it's okay. The Java compiler is going to let that slide. Why? Well, remember the difference between this class here that implement list is that empty is a class. So that means I need to be able to create objects of that class. That's what a class does, right? We use it to create object. Well, how could I create an object if it says that it implements a list, so it has to implement a bunch of methods, but there's no code for the method? That object is dysfunctional, so Java prevents that. But when I say that empty is an abstract class, being an abstract class means that you're not meant to create objects. It's your subclass that are meant to be used to create objects. So Java is okay with you saying that this abstract class is supposed to implement, this interface, but hey, I didn't provide the code for the method in the interface list inside my abstract class empty. But guess what? All of my subclasses are bound to implement those methods. So when I have a public class child that extends empty, the abstract class, this one is going to have to implement the method. And guess what? If it does not implement the method, if it's an empty class or is missing some of the method, then Java is going to complain because this time it's a class. So it's meant to be able to create object, but I cannot create object if I'm missing some methods. Okay? The method that were actually promised in the interface list, that the abstract class empty said, well, don't worry, I don't implement them, but my subclasses will. And then when we finally go to the subclass that extends, empty, we realize that we still don't have those implementation. That's where Java is going to catch up. Okay? What about abstract classes versus interfaces? Well, an abstract class can do everything an interface can do, right? And more. So when you are in a situation like that, it's healthy to ask yourself, well, why do we feature both interfaces and abstract class in Java? Why have the two features if actually the abstract class is kind of a better version of the interface? So here's what you need to understand. So first thing that we have been repeating over and over, Java has single inheritance. Okay, so one class, any class, can only extend one superclass, but it may implement many interfaces, no problem. Okay, so having interfaces allows a class to be a part of a hierarchy, of an inheritance hierarchy, if you will, and use polymorphisms without using up its inheritance relationship. Okay, so this is a very lightweight mechanism when you do not need actually to share code at all. All right, so if you were using abstract classes everywhere, you would lock yourself up again in the same situation that we had originally motivate us to explore interfaces. Okay, yes, abstract class can do everything interface can do, but if I use abstract classes, then all of my classes have to subclass that abstract class, and I cannot do any more inheritance with them. Okay, so if I want to be able to, implement multiple interfaces, I do need still to use interfaces. What about abstract class versus regular classes? So these slides are like trying to pretty much, go back over all the combination and make sure that we understand why, there are so many features in Java. Try to eliminate the possibility of a feature that is redundant or that we don't understand exactly why it's not considered redundant, okay? So in this case, our observation is inheriting from an abstract class can do everything inheriting from a regular class does. Therefore, same logic, right? Our logic is, why do we have both mechanisms? Why do we have abstract class and regular class? Okay, answer to that. The abstract class forces subclass to implement some of the method. Okay? And the main benefit here is we are unable to construct new object from an abstract class. We are unable to compile a subclass of an abstract class if it's not implementing all abstract method. So bottom line is that we have the benefits here that interface is brought us in terms of my abstract class is marked abstract so that I cannot make objects. I have to make a subclass of it, and I can make object of that subclass. And once I make a subclass of it, in order for that subclass to be operational, to be functional, and be able to create object, it has to abide by the contract that has been defined in the abstract class. So if the abstract class said, here's a method, I don't give you the code, but my subclass will. If you claim to be a subclass of an abstract class and you're not yourself abstract, you want to be able to create objects, then you'd better implement all of those abstract methods that were inherited from the abstract class, okay? So think about this, okay? It doesn't hurt to make a table on a draft paper or something like that to summarize all those cases after you listen to this video, okay? But the idea is really that there are subtle differences between abstract classes, interfaces, regular classes, between the implementation of an interface and the inheritance from a superclass, okay? But none of those should appear redundant to you. Try your best to find an example where you could claim, I can do everything that, for example, an abstract class does with an interface, and then try to prove yourself wrong. If you can prove yourself wrong, if you follow the logic and you realize, why you cannot completely replace everything by abstract classes, then you have a solid understanding of those different concepts.